Okay, so today we are doing, or we're going over 2 vocab words that they love to put in trig word problems. So we need to know what they mean in order to do those trig word problems, all right? Now, we're learning about the angles of elevation and depression. First, we're going to do the angle of elevation. What does to elevate mean? To go up. Yeah, to elevate means to go up. That's exactly what the angle of elevation is. Shh. It goes from the line of sight, it's called, to, or looking up. So it's from line of sight looking upward. Now, what this line of sight is a line in your diagram. It could either be from a person's eye, so clearly you can see, okay, straight ahead is their line of sight, or like in the bottom problem, it is a line that is just parallel with the ground. All that you need to remember for line of sight is that it is always a line parallel with the ground. So the only line parallel with the ground in this picture is this line right here. This is our line of sight. Now, what angle starts at that line of sight and goes upward to reach its second line? Which angle starts at the line of sight and goes upward? Morning.
What was the question again?
What angle starts at the line of sight and goes upward to reach its second vertex there, its second line?
You mean the hypotenuse side, right? That one is this one.
Which one's your line of sight?
This one's the line of sight.
Good. So you start at that, and which one goes upward to reach its second line? Which angle? Is that an angle?
Wait, angle?
Never the right angle.
Wait, I don't know.
Does anyone want to take a guess? Not the right angle. So you mean this angle?
No.
No. You mean the left angle? The right angle? All right.
Oh yeah, I actually don't understand.
Okay.
45.
Okay, I didn't understand.
So you're starting at the line of sight and you're going upward to reach the second line. This is right here is called your angle of elevation.
Oh.
You're starting, so if you put your arm out, right, to designate or to signify the line of sight, and you move your arm upward, you're creating an angle of elevation right there.
Does elevation have a T in it?
No.
Elevation?
Yes. Your angle of elevation at the end, yeah. It's a T. See how it like connects right there?
Oh, I see. Okay, I
So obviously you guys are like, what? And I don't really, no other classes had issues with this except this class, so it's kind of weird.
Wait, it's basically looking and then like that.
So where's our line of sight? The bottom, right? It's parallel with the ground. And where's an angle starting at that line going upward? Yeah, where? Where is it?
On the right.
It's on the right this time. It's right here. This is our angle of elevation. Is your angle of elevation ever the right angle?
No.
No. Nope. Just like your trig angle is never the right angle. Same exact thing. So here, let's try an example. Emma P. Alex casts a shadow that is 5.25 feet long. The angle of elevation to the sun is 48 degrees. How tall is Alex? So, where is Alex's shadow? Yeah. So, if the sun is behind or in front of you, your shadow is going to be behind. Your shadow is going to be behind you right here. It is 5.25 feet long. And then it says the angle of elevation is 48 degrees. Where is that angle of elevation in this picture?
On the right.
On the right. Yes, you're starting at your line of sight going upwards. This is our angle of elevation, with it being 48 degrees. And where's our X? The person, right? We want to know how tall Alex is. His height is X. Now, how do we solve for X? How do I know I use trig here? What's my clue? There are two sides and an angle. That's how I know I use trig. So what's my first step in trig? Label with O, A, and H. And of course always theta. Then what do? You box the labels being used. So which labels have X's or numbers? O and A, and as always, theta. So which one, so, ka, or toa, has an O and an A? Toa, and what does that T stand for? So tan of theta is equal to, what's the second letter in toa? O over the third letter? Yes, A. Now what's your theta in this problem? 48. So I'm going to replace theta with 48. So tan of 48 is equal to, what's O? And what's A?
5.25.
Now what do? Yeah, how do you solve? X is in the top, so what do? Multiply tan 48 times 5.25. So in our calculator, we're going to put tan 48 and parenthesis times 5.25. And we should get 5.83. Is this an angle?
No.
Do I put degree? What do I put? Feet. He is 5.83 feet long.
So like 5
These make sense to you.
Yeah. Yeah. Maybe a little less. All right. Now, are there any questions on this problem? Are we still confused by where the angle of elevation is? Right? It's just you start at the line of sight and you go up, right? You're elevating. You go upwards from the line of sight. Now, where do you think the angle of depression is going to go?
Down.
Down, right? To depress means to go downwards. So it's from line of sight looking down. So in this picture, there are two lines that could be our line of sight, right? The top and the bottom could both be our line of sight, because the only distinction for line of sight is that it's parallel to the ground, and both of these lines are parallel to the ground. However, we're starting at the line of sight going downward. For this bottom line, is there an angle going downward? No. Is from this top line, is there an angle going down? Yes, right here, right? So we're taking this to be our line of sight. And this angle going down is our angle of depression this time. Now, what do you know about the top and bottom line? Okay, them being parallel actually tells us what about this drawing? We have two parallel lines cut by a transversal. What has been created? Ah, our little Z here, right? Our two parallel lines and then transversal, and we know the inner corners of the Z are what? Alternate interior, meaning they are congruent. Guess what is another name I could call this angle right here? Oh my gosh, it is an angle of elevation. So what do you know about the angle of elevation and the angle of depression? They're the same measure. Why do you think that's important to know? Can anyone see it before I give you a hint? What specifically do you notice about the angle of depression and its location?
It's up top.
It's up top, okay. Shira, what do you have? Oh, you.
Oh, it's when
It's what?
it's inside.
The angle of depression is.
It's what's alternate interior.
Yeah.
It makes a rectangle.
Yeah. All right, let me give you a hint. This is our right triangle in this picture. Where is the angle of depression? Yes. In comparison to that right triangle. Where is it? Oh my gosh, it's outside of the right triangle. Do you think an angle outside of the right triangle is immediately solvable with trig? Can I use an angle outside of the right triangle? No. Right? You have to have an angle inside the right triangle. But now, because we know, oh, that top angle is the same as that bottom angle, if I'm given the angle of depression is 30, I now also know that that angle of elevation is 30, and now I can solve using trig. Does that make sense? For the most part. So for instance, if they give you a problem, like say, I'm standing on a cliff, and I throw my math book over the edge, and it lands there, right? And it says that we want to know how far the book lands from the edge of the cliff. And what else? Oh, then it says the cliff is 20 feet tall. And then it says the angle of depression is 40 degrees. Can I immediately solve for this? Immediately.
Yes.
Immediately?
Technically,
Oh, well, you have
Technically, no.
but you gotta put the
What do I need to do with that 40?
angle of elevation.
Make it the angle of elevation. So what other angle is 40? Which is where?
Right there.
Now I can solve using trig. Does that make sense? More sense than it did before?
Yeah.
Okay. Any more questions on angle of elevation or angle of depression?